All right. Well, welcome everybody. My name is Sarah Black, and I'm the Manager of Education Programs for Canadian Geographic Education. This is our last session of the day before our concluding keynote, and I'm very excited to introduce today Alex Smith. He's a higher education specialist for Esri Canada, and he's going to be talking about GeoAI, which is, in my opinion, a very relevant topic in today's education system. Before we get going, I just wanted to highlight a couple of things to make sure we're all connected. The first is the chat function. If there's anything you want to add, if there's a link, if you want to network with other people attending, please use the chat for that. If you have a question geared specifically for Alex or even myself, just add it to the Q&A. If you accidentally add a question in the chat, I'm going to be monitoring everything in the back end of the presentation anyways. And Alex has asked, by all means, ask your questions throughout the session. They will be saved. And Alex has asked that we will have a designated Q&A session at the end of his presentation, and he will address those questions then. So without further ado, Alex, I'm very excited to have you here today. I'm going to let you take it away, and I'll just share the link to your presentation right now.
Awesome, thank you. Yeah, today I'll talk about Geo AI, but first I'll go into a little bit just about how I got here. So I grew up in Guelph, so I'm not sure if any of you have taught in Guelph, but you may have taught me. Then Waterloo for my undergrad and master's, doing basically pure GIS. So part of the geomatics program. Then off to Simon Fraser out west to do my PhD, and that was in agent-based modeling and spatial stats. From that, went to Esri Canada, where I now work in the education and research group, focusing more on the higher ed side of things. But I was asked to come here and talk about Geo AI, so I'll get started with that and just go over basically what it is, how it works, and then some examples that you can do with it. So we do have this survey if you want to fill it out, just to tell us who you are, like where you are from, stuff like that, just so we can help to like change how we present our topics to sort of more align with like who we are talking to. So I'll leave this up for just another second here, just in case you're still scanning or typing in the link there at the bottom. Um, but it's a fairly short survey here. Okay, I'm going to start to go past this. So first, let's cover what is Geo AI. So um, I'm not sure if you can see the video I have here. I think it's blocking a little bit here for me. But so Geo AI is using AI within geospatial applications. So when you think about AI, you might think of like movies, apps like the Terminator, or maybe you have like smart speakers at home with like Siri, Alexa, stuff like that. Or maybe you've gone further, about like neural networks, deep learning, and like the Turing test and stuff like that. But it's trying to imitate human thinking through like coding essentially. But then on the geospatial side, this is everything that has some sort of spatial property to it. So this can be like cities, so say like mapping cities where people live, so where like the population is, where different types of people live. It could be like mapping the roads, like weather and like climate too. Um, when you use your phone to like drive and you do like the Google Maps, you'll have like directions in it, and that's like the geospatial side. And I think that might also have some of the AI side in it too. So there's a lot of different ways to use AI within geospatial, and I'll go into a bit of that here. But let's focus more on AI for now, just to get a better understanding of what AI is. Um, so AI is a very broad field. There's no sort of one type of AI. It's a lot of different things, and it's just trying to imitate human functions using like using coding. One form of this is the machine learning. This is probably the biggest field within it. And this is how the computer learns from the input. So you give it a bunch of inputs, and then it trains itself on it to try to figure out what the answer should be for any new data. And then within machine learning, we have deep learning. So this is just a type of machine learning where it uses a neural network, which is the next thing that we'll talk about here. Um, so there will be a bit of math in this, but you don't need to know the math. It's just more about knowing that, like the general sense of what's happening. So a neural network, based off its name, is a network of neurons. So there's different types of neurons, and they're arranged into layers. So you'll have like your input layers here on the left, here in green, and then the output layers here on the right in this pinkish purple. And then everything in the middle will be your hidden layers. So this is just hidden because we don't usually interact with it. So we will interact with like the input, and we'll interact with the output, but we don't really interact with this middle section. It's sort of like a black box. So each of these circles represents one like neuron, but really most networks will have millions of them. This is not a small model. These are often very large. So you might have like 100 layers, and each layer will have thousands of neurons in it. And usually they'll have something at the start and end to sort of transform your data into something that the neural network can handle, and then output something that like you can understand from the network. So there's all these different layers in it. And yeah, so what happens is you have your input neurons here. So maybe this is like, think about it like your eyes and ears. This is something that's taking data and pushing it into the model. And what this does is it makes every single value, which is a number, it makes it visible to every single neuron in the next layer. So that you can see all these lines here connecting every neuron in like the first layer to the second, all the neurons from the second to the third, and then so on. So every neuron can see everything that happened before it, and it makes its value visible to everything after it. And in future diagrams, I'll just put a big X in it just to show that's a fully connected network here. So I'll go on to the next slide. So one neuron sort of looks a bit like this. You'll have the input. This is just the input from like the previous layer. So if this is the like the actual input neurons, this is going to be from like whatever you're putting into it, like an image, your text or something like that, turn into numbers that the neuron can handle. Then you also have this bias here at the top. This just lets the model tweak the different neurons to show how like strong the neuron should be activating. So like what the final value is, you can just tweak it with this here. And then you take the weighted average of all of these numbers here to get the weighted sum here, and then you run it through some sort of nonlinear function. You can see here this is just the sigmoid function. It's fairly classic function, although it's not used as much anymore. And then you get an output. So like what's happening here is just a lot of very basic math. So you're just taking the weighted average, take that number, turn it from zero to one, and then make that value shown to the next layer. When you're training the model, what's happening is that these weights here will be changing. So you'll put data in, and then you'll get the result for starting with just like random values. You'll look at it and say, this is right or wrong, and then you'll edit the weights to be more similar to the correct answer. And then you do this millions of times, and then you'll get a model that works a lot better just through this training. And it's very complicated process that I'm not going to really cover here, like how they actually edit the weights. But you can imagine it's very complicated when you have to go through hundreds of like layers back to try to find the weights at the start that's going to influence the results at the end and stuff like that. So it's a lot of math that even I don't really get. When you have multiple neurons, the output turns into the neuron for the next layer. And here I'm showing two, but you can imagine that this output here from this function would go to multiple neurons. So like the input for the multiple neurons. The weights between them will be different. So the weights for like one neuron will be a unique weight to that one neuron. And also, so this function, so we had the sigmoid function earlier. This might change layer to layer, but it's usually the same through one layer. So like one layer will have the same type of function, but different layers can have different functions just depending on how you've set it up. But usually this isn't something you have to worry about. Most times it's just tools deal with all of this for you. So when you actually use it, it can get fairly complicated in terms of how the model itself work, but from an outside perspective, it can seem fairly simple. So, well, relatively simple, I guess. If you want to apply it to say text, so this is a common thing. So this is like when you're using a chat GPT sort of thing. You will type in text, but it has to turn it into a number. So you will encode the text into a number somehow. Usually this is done through a series of these like tokens here. Here I've shown them just as single words, but usually it is parts of words or like the like the end of one word, start of the next word. It's a fairly complicated process, and there's lots of different ways of doing it. But again, this isn't really something that you need to worry about. It's just cool to see how this works on like the background. So you take all these words or these like tokens, turn it into numbers, run it through the model, get the output, and then depending on what the output shows, maybe you might have a neuron where each one is one word, and then like the highest activation here is then the word you want to finish the sentence with. So say apples. So I'm going to the store to buy apples, or maybe you have a whole sentence based off what the output is. When you're using these bigger chat models, they use large language models, and usually this involves um, uh, many of these networks that can pass values back and forth, and um, and I have a video at the end that you can watch if you want to learn sort of more about how that works. But it's as you can guess, it's a very computationally intensive process. That's why they have servers that cost millions and millions of dollars to like run and like train these models. Within GeoAI, this can be used to like standardize addresses. So if you're the post office, maybe you have the input from like the postcard which you're trying to find the address for, and someone's written it in like an odd way. You can use GeoAI to look at the text and find the address based of how they've written it. So if maybe they've said street instead of ST, maybe the model can turn that into street so you get the full word spelled out and stuff like that. There's so many different ways to use it for that sort of stuff. And also what you can do is like within data, you can try to classify it based off the attributes of the data. So maybe this is comments on like a restaurant like rating site. So you have like all these points for all like the restaurants, and based off the comments and like the price and stuff like that, you can sort of classify them into different types of restaurants or really anything you want. AI can do a lot. It's just being able to build the AI the way you want it. If you want to do an image, which is sort of like the classic Geo AI like use of it, there's different ways of doing this, but the really simple way is just putting each pixel into the model, but first turning it into a 0 to 1 value. So in most imagery, so you can see here there's a car turning on this road. So if we just zoom in, we can see each pixel. Each pixel will have 3 values, so the red, green, and blue value. So what I've shown here for these 2 pixels. To turn it from a 0 to 1 value, we will divide it by their maximum value. And if this is a 8-bit image, the maximum will be 255. So turns into these numbers. You put it into the model, and then at the output, you might get car or road, depending on how you've trained the model. But usually you won't just put the whole image in. Usually you will use small tiles and classify each pixel, or maybe if you do want to do this whole sort of image here, you'll need to do something else to it first. So you can do a convolution. And basically this is just a bunch of filters applied to the imagery to pull out different features. So this might be straight lines, curved lines, stuff like that, like areas of like high contrast, basically anything which can help the model figure out what is shown in it. So you might imagine for like a car, these filters might pull out like a line angled at like a, I'm not sure what angle that is, but it's some lines along this angle, and it might pull out eventually after like a few of them these like rectangle objects, and then through all these filters, it can classify these like objects as cars. So there's different ways of doing this. There's no one right way. There's many ways. But when you're trying to classify pixels, usually what you will do is that you'll have a moving window. So you can see here, I have this red box here, and it moves one pixel over in every step here. So what you do is you take these pixels. I've just shown it here, 3 by 3, but usually this would be much larger. It's just easier to show it here with the 3 by 3. So you take these values, plug them into your model, and then it outputs what class it is. So say this is pavement or car, tree, grass, house, whatever you have trained it to find, and then it assigns the center pixel to be that. I'm just going to move this video here. I'm not sure if you can see it, but let's move that in just in case. Yeah, so you can see here now a pavement has been assigned to the center pixel, and then this pixel here would now be pavement. Then you move the window over one, and you do the same process, and you do it over and over again until you've made your way through the whole image, and then you classified every single pixel. Usually you would also need some sort of way to handle the edge cases where you won't have the perfect 3 by 3 grid, or 100 by 100 grid, or like whatever size window you have here. And this can be used in many different ways. So within the urban environment, you can get input from sensors such as traffic cameras, satellites, planes, drones, stuff like that. Or like maybe it's like weather stations, so it's not imagery, but it's just like data, so like like the various weather stats, or maybe just like people's phones. This could be people taking photos. It could be tracking where they're going for say traffic or something. You can bring this all in and then use AI to sort of process this. Because image is the standard one, I have some examples here. So here's a traffic camera, and I've just added the boxes to sort of show how this would work. I didn't actually have a model to show for this one, but you can have AI pull out the cars, and maybe this is to give tickets for running a red light, or maybe this is to track where the cars are so that you can change the lights early, or hold the lights off to change later so that you can make the traffic flow the fastest possible, but you can. So this is getting more and more common. I think Amsterdam, I think is starting to implement this a lot, and like more cities are like starting to bring AI into these traffic cams to help the lights work smarter. On the second one here, this is going to be for something like, say, hurricane damage, tornado damage, flood damage, anything like that. This one here is taking a image and is looking at each house and trying to figure out how damaged the house is. So the blue houses, I believe, are the undamaged houses, or like the no visible damaged houses. And then the red is all the damaged houses. So you would think, maybe after a big storm, there's going to be blocked roads, downed power lines. So it's easier to just to fly the plane over a few times with a camera mounted to it, bring it back and just process the data, and then it saves you having to send people out into a possibly a bad place for them to be that might be really slow. So this is just a lot faster. Or if you're in a city again, maybe you are trying to find cracks in roads, so you can drive a truck along the road, or fly a drone, fly a plane, and use AI to find the cracks in the road. So they might be hard to see here, but all these cracks are all found, and you can then figure out how much work a piece of road needs. So you might be flying the drone along all these roads and then process it and be like, oh, this block needs to be worked on first because it's the most cracks in the road. Or like power lines here on the next one, you can look at the different structures within the towers, and maybe you can look for damage in it. Or say for self-driving cars, or trying to um, look at assets, you can look at the text on signs to make sure that that you can still read it, or for the self-driving cars that they know what to do because they can read the sign, get the text out, and then figure out what they have to do so they don't turn down the wrong way. They can follow the one-way sign. Within the natural spaces, you can use it for like other things too. So this left one here, so this would be a satellite imagery. I think this is radar. You can find oil spills. So you can just have this running and have it automatically find oil spills for you. So you don't need to be constantly looking for it. You can just run it through the model. Or you can use it to like count species. So like this like third one here, these are seals. So maybe you fly the plane over the area which you know the seals are, and then like use AI to count how many seals there are for like your research project. Here in the last one, this is just the classic land cover. So you can use AI to figure out what each pixel is uh, based off the image and sort of what is like around it. So just makes this faster, so you can sort of track urban growth, track how much like green space there is in your city. Look at national parks and stuff like that. So there's lots of different things here. And oh, and then the input for this is basically the same as the city, but you might have slightly different things. So you might have like trail cameras. You might do like a soil type survey, a vegetation survey, and stuff like that. Within our software, there's many ways to use AI. It's sort of really going into every single product which Esri makes. The two big ones in terms of data processing would be within Pro and then also in online. So both of these can handle, I think, basically any AI model which you can make, and it sort of overlaps into like both of them. So you can run any of the models which I've shown here actually, except for the traffic camera. These are all examples from our online source, which I'll show in just a second. So like Pro is more like the desktop-based software for doing data management and more complicated analysis, and then online is more for like collecting data, sharing data, storing data, and stuff like that. Although it's getting bigger and better every single day, it's almost a full online system now, like in terms of a full GIS system online. And then they both do GeoAI mapping, design, stuff like that. But GeoAI is the big one for us here. So yeah, so all the examples which I showed above here, just with these photos, these have all been from our Living Atlas. So this is a source for data online that you can pull directly into your mapping project. So if you're doing a project with like students, you don't need to go looking for data quite as much. You can just search the Living Atlas and be able to find data quickly. One thing which they have on here are a bunch of pre-trained AI models. So these can run in Pro and in online. And basically, you will get the model off of the atlas, get the correct imagery, and then put it into the Geo AI tools, and it should run just without having to train a model or like anything. So you get all the benefits of having a model trained on tons of data, except you don't have to put in the money and like the time to actually train the model. It's just right there for you. So it's a pretty good source for like models, and it's something that I've been using a lot for my own work here. One thing which you might use a lot of would be the survey 1, 2, 3 um, surveys, and it has a new AI assistant built into it. So this is something where it basically creates a survey for you. So this has to be something enabled by the admin. I'm not sure who that would be. Probably someone at the school district, I think. And this would be so if they turn it on, it's still in beta mode. So it's free for now. Who knows what the process is going to be? I'm not really sure. That's up to Esri Inc. for that. But what you can do is tell it what you want from a survey. So it's probably really small text, but you can see here I've told it what I want. So I want to create a survey for students to map trees. Um, and I want them to have to give their teacher's name, and then I gave it four names. Um, I want to look for certain species, so I've given it one, two, three, four, five species, a unsure, and then an other. And then they also need to give some stats, so the height of the tree, how like big the tree is around, the health of the tree, and then able to like upload a photo and then show on the map where they found this tree. Um, oh, and there's a link here which you can go to if you want to see more about how this works. So once you do this, it gives you a little sample, and then you click on the generate button, and you can see here this is a survey. I've edited it very slightly, so I added units onto the two questions here, and then I had to add other onto the trees, and you can see it fills in the teachers and the various things here on the right, like totally automatically. You don't have to pick the type of question; it just goes through and just fills it in for you. So this is a really great tool to use if you're trying to like test different surveys and trying to think of what you want it to do. You can just tell it what you want, and then just goes and just does it for you. So this is a really cool tool. I hope that this is something that gets used a lot because it makes surveys really easy to make. So you can see this video playing here. It's probably small text, depending on the size of your screen, but you can see here the drop down has all these teachers there. And yeah, it has all the trees already in there. It has the right type of field to put in numbers for the height, and then the size of the tree. It has some values for the health, and then a space to put in the photo, and then click on the map. So that's everything I changed, or which I put into the text box. The only thing that I had to add again was these units within the titles for those two questions here, and then here. And I did have to add other as like a species so that they can click other. And one of the cool things with this is that within a survey you can have multiple languages. So this is good if you're doing a school that has English classes and then also like French classes, and you want to do the same project with them. You can have it auto translate your whole survey for you. So you can see here I've gone into the to the manage survey languages here, and then you can auto translate into a few languages. So it's not every language, but there is I forget how many there are, but there's something like 16 to 20 that's currently in there, and I think they're going to grow more and more. So once you click the auto translate, it thinks for a bit, and then you can see here I haven't edited a single thing. I also don't speak French, so I don't know how accurate this actually is. Um, but it gives you like a great starting point. Then you can then go in and fix any errors. Like AI is not perfect, but it's pretty good. So it's definitely good to fix errors, but just makes it easier, right? Anything that saves time is always good. Oh, sorry, I missed one thing here. So, again, this might I can make it bigger. Yeah. So this is sort of like what sort of AI features are in the various survey products. So within the web, so where I was showing that you have the assistant to build the surveys for you, and then this auto translate feature. But if you're using the Connect or like the Field app version of it, you might lose the assistant for now. It's probably going to come into it at some point, I would guess. But you also gain these other smart features. So this is where you can put an image in and then use a AI model to do something to that image. So you can redact things, so say blurring faces, license plates, and stuff like that. You can say what's in the image. So you can annotate the image with say car or tree or stuff like that based off what's in the image, stuff like that. So it's just these new advanced features which are sort of just coming out now. So like I think even this stuff I couldn't have talked about 4 months ago. So it's like it's pretty cool to see this all coming out. I'm just gonna check time. Yeah, okay. So I have another project which I've been working on. This is sort of like one of my big things I've been doing. So I wanted to share just to show how we're using GeoAI for more of like a data centric research project. And for this, we're trying to find missing roads on the map. So it's probably well, it's a fairly rare occurrence that a map has a road missing. But if you've moved somewhere into like a new build, you might notice that the road which you live on might not be in all of the maps instantly. It might take time for the road to be added. Or like maybe there's been a road that has been changed and it still shows the old road, not the new road. Or there's also errors that happen. So there's different things for like a road to be missing from the map. It's fairly rare, but it does happen. But it is important if you live on the road. So in this image here, I've taken out three roads. So one here at the bottom, one here in like the middle, and one here on the right. And if you live like in this house here, and say the fire station is over here on like the left side, upper left, and they're trying to get to your house, they want to know the fastest way there. So if they're local, they might know that this road is actually there, even though the system is saying to not take this road. But if they're just following what their truck is saying, they might actually go the long way around and waste precious time trying to get to your house just because their system doesn't know that this road is missing. So that's sort of like the main the focus for this is to find these missing roads so that the fire so that the fire department can find you, Amazon can find you, or like anyone really, just to make the map more correct. So the first method that we're doing, well, in terms of the AI methods, we have other methods, but I'm going to focus just on the AI side here. This is using one of the pre-trained models from the Living Atlas, and there's a road network abstraction model on there. And this has been trained with a huge data set. And then it's uploaded there. So what we've done is that we've taken that model and then we're using transfer learning where it takes that model and then our new data to make it local, and it just tweaks the values to make it better for like our data. So like our type of imagery, our type of roads, and just makes it just makes it just that little bit better. I think the numbers are like we can get 10% more roads out of it. So just makes it focus on our study area. But you still get that huge benefit of all that training from all that data already done for you. The second way was to make a custom model, and this is where you can make it fully custom to what you need. So what we did for this was we took out roads from the map just because it's hard to find the roads. That's what we're trying to do. So we took out roads to make them like fake missing. And we embedded the roads into the image. So you can see here we've added a fourth band into the image, and then I've shown it as the red band. So these red lines are all the roads, and I've taken out these same three roads from that. And then what we do is we take those missing roads that we've taken out, and then we tell the model, hey, find this road. This is a road that is missing. You need to train yourself to try to find roads like this. So then I give it my 750,000 samples, and it goes through and it learns how to find these roads. And then you would give it a different area. And I've taken out, so this is just the same area, just so you can see the different parts of it. And so like this wasn't trained on this area, which is bad to train it on the same area as you're like testing it on. So like this was trained on a separate area, and then I ran it here, and you can see here it's found these like missing roads almost perfectly. So like you might notice this little red area here. And basically the training data which I gave it at the end of dead end roads, it has this little like circle on it. And so it sees this without a circle in it, it's saying, hey, there's something wrong here. But there's not enough space to put the circle in, so it's just putting this little red mark here. So then, with this, if you didn't have these sort of fake missing roads that I've just pulled up, but you had actual missing roads, it would then find it for you automatically. So instead of having to pan through the image for hours trying to find that one missing road, it's just going to scan it. It might take half an hour to like process, depending on how you are running it, and then and then it finds roads for you. So then you process it, you compare it to different sources and like the previous way of finding roads too, where you find all the roads, and then at the end you get this flag basically saying, hey, there's a missing road here, and then you send that to the city of Toronto, city of like Vancouver, there's like like whoever owns that road, and tells them, hey, you are missing this. You should probably send like a survey crew out to do this. There was a missing road found in Toronto, which I heard of. This was like before we started the project, and we well, not we in terms of me, but like someone at the company told them, hey, you've got a missing road here. And it turns out what happened was that they just didn't turn the road on. So they had the road mapped out and like everything, but they just didn't have it flagged as being an active road within the system. So like the next day, the other road was shown. So it might be a really simple fix like that, just to have these roads shown, but they need to know about it. So that's what we are trying to do here. Make sure that our maps are the most accurate maps that we can. We have focused more on cities. So the next step would be a rural area model. So this is a road that I've been trying to drive up for probably 10 years now. So this is the Idaho Peak Forest Service Road. Um, and basically this is a Forest Service road that is maintained by a logging company. And I forget when, I think maybe like 6 years ago, there was a big storm, and it got washed out at different places. And then the logging company, because they're not logging here, they just put big boulders at like the base of the road and said, roads closed. But here I have a screenshot from Google Maps, and it still shows it as being an active road. So I've seen this, and I wanted to go up and then like hike this peak, because from this parking lot right here is a really short hike to the peak, and it's a really great view. And it turns out the road's closed, so I haven't been able to hike this road in, you know, well, since I heard about it basically. Um, and then like who knows when it's going to be opened again. This is about a half-hour drive away from that other road, and you can see here in these trees, there's all these um like lines, and these are all roads. So so like Forest Service roads, and these are active. You can see there's some cut blocks here, but there's also a mountain biking lodge here, and they have these big trucks that they drive people up the mountain, drop them off, and then they bike down. And this is a hike that, or like I guess these are roads that I've driven on to a hike, but when we did it, we got lost. So we took a wrong turn because it's not mapped. There's no signs or anything, and we're driving thinking this doesn't look quite right. And then we ran into one of the big trucks coming down, and turned out that it's our friend. So we're like, hey, we're trying to find this height, this like hike. So it was the Rico Mountain hike. We're like, how do we get there? So then he gave us directions through these roads, and we did make it. So this is me here at the top. Yeah, so we did make it eventually, although we got lost. So the goal is to find these roads, put them on the map so that people don't get lost trying to take them. Yeah, so that's most of my presentation. I do have some links here. So I've so like this link here has been shared in the chat, and I have some videos here. So these first three here, just about general AI. So I forget which one's which right now, but one of them is by a YouTube channel, Three Blue, One Brown, or Three Brown, One Blue. I get it mixed up sometimes, but they have a great series on like AI and like and like how it works. And then the other one, so this other like a playlist. This is from MIT, and this is a AI course, like an online course which they have, and you can go and take the course, but they also post the lectures online free so that you can sort of like follow along with them. So it's really great resources if you want to learn more about like AI. That's definitely the place to go. So yeah, that's all I have for this today. I guess if you want to switch to questions.
Yeah, Alex, we do have one question. First of all, thank you. That was fabulous. And it's also, there's so much, it's like an onion, like there's so much to know about this. So really appreciate you sharing this. One of the questions we have for you today is, how does GeoAI work with changes of imagery resolution, like pixel
Mhm.
sizes? For example, satellite versus drone imagery. Are you able to address that?
Yeah, so that's something that we've been having hard time with. I'll just go down to one of the ones here. So where did I have the pixels shown? Um, so most models, well, I guess all of them will work the best on the data which they're trained on. So if you train it on a one meter image, it'll work best at exactly one meter. But it can go a little bit beyond that. So if it was a 1 meter image, I would expect it would do like like a passable job on like a maybe a 50 centimeter image up to like 1.5, maybe a 2 meter image. Um, but yeah, like the further away you go from that, from like what it's trained on, the worse it's going to do. But there are models that can take a blurry image, so like this one here, and you can use a model to predict what the higher resolution image would look like. So you can get, I think this is 50 centimeter, which I've done here, and you could use the model to get 25 centimeter, 10 centimeter up, possibly. But like you can't create data from like nothing, so it's just the prediction of what that would look like. But yeah, so just the further away you get, the worse it gets.
Perfect. And just for people coming in, you were talking before about the AI technology connected with Survey 123.
Yeah.
Jean is in the session, and she just wanted to highlight to our educators tuning in today that if anyone is interested in having the Survey 123 AI tool enabled in your ArcGIS online account, just to send an email to k12@esri.ca, and then the Esri team will work with your IT people and assist with that as well.
Great. Yeah. Like it should be a fairly easy process, but but our team here is, like willing to help get that set up for sure.
Any other questions? Perfect. Well, I think everybody is still kind of digesting the information. Oh, I see, Sandy is saying a huge thank you, and that she likes using AI to help out as well.
Yeah,
Um,
AI is great. There's so many different things that you can do with it. And it's just amazing seeing what's coming out like every day.
Wonderful. So I'm happy to stay on, and for any educators who want to have a discussion, or if you, I mean, you have access to a very knowledgeable gentleman from Esri Canada. So if anybody wants to ask a question, or if they have an idea they want to throw by Alex, um,
And so the DEM, so depends on the model, and if you want to like depends on what you're doing with it. So if you want to interpolate DEM, what you would need to do is have like a low res one, and like the high res one for the same place. Train it on that so that you can sort of learn what is like between pixels, and then it just and then like it would just guess at it. It's not going to be perfect. It's just going to guess at sort of what might be there based off what it's seen previously. So like the AI models can't create new info. They can just like predict what is coming next.
well, with that, Alex, we can just conclude our session. And again, if anybody does have any questions, you're more than welcome to email. I'll put info@CanGeoEducation in the chat, and then attendees are more than welcome to email me, and then I can either throw it to you or to Jean and her team for any additional questions. And this
Great.
session has also is being recorded. So once we finesse the videos, we're going to put everything up on a private YouTube link and share it with all of our attendees and presenters. So you can always revisit this presentation as well. So without further ado, I'd love to just conclude and say a huge, huge thank you to Alex and sharing your knowledge with us. And I will happily stick around for anybody who wishes to ask any other questions, either Esri related, AI related, CanGeo education related, and have a wonderful afternoon.
Thanks for having me here. It's been great.
Alex, while we have, like 5 minutes left, is there any cool project you're working on that you want to share with, that you're allowed to share with us, or?
So that road, so the missing road one, that's sort of like the most that we can share about the work that we're doing for that sort of stuff. So like there's more to it, but sort of just like that's the stuff that's been like made like public about it. It's just like the general process and like what we're doing with it.
Perfect.
Yeah. It's been a really challenging topic. And like we've had special like workstations with like the big like graphics cards in it, just churning through data, trying to make and better models. There's one that I'm running. I think I haven't trained it yet, but I think it's going to take like if it does the full thing, it's going to take about two weeks of just constant training on it.
Oh,
Um,
wow.
so it's not a, it's not a quick process for the training, but once it runs and it runs, in terms of like trying to find new roads, and it runs really quick. So it should be good for that.
Is there any other, like, do you have a, like a dream or a passion project you'd like to like one day work on or apply your skill set that you have learned to?
Oh, one thing, so it's not something that I could really do here, just a different, just a different sort of thing. But I think so I really like racing and like the it's like the F1 races and stuff like that. And I think it would be cool to create an AI to sort of like map where like what like paths like the cars should take on the track, like live with the other cars for like overtaking and blocking them and stuff like that. I think that'd be a pretty cool project to work on. Some sort of like live, sort of like driver assistant sort of thing.
Perfect. You can practice at Sobel Speedway, right?
Yeah. Yeah, it's pretty close to here. Yeah, but there's so many different so many different things that you can do with like AI. It's really like what you can think of and what you can get data for. That's the two things. So if you can think of it and there's lots of data, then you can probably make it.
Yeah,
It's just, well, also if you have the resources to like train it.
yeah.
Yeah. That's
No,
the
that's
nice
really
thing
good.
about all of our pre-trained models is that the work's already done for you.
No, absolutely. That's one thing that coming from Canadian Geographic, and we make lots of maps and everybody's like, oh, it would be really cool if there was a map on this. And you're like, but there's no data on this. And
Yeah.
it's making that connection and collecting data.
Yeah. And data is always like that one like limiting thing it seems in every single project. It's like how do we get like more data?
Yeah. It definitely encourages you to be creative storytellers because of
Mhm.
what data you do have access to, and then how you tell that story using map or using Geo AI, for example. So it's a form
Yeah.
of storytelling. Hmm.
We have we have a map challenge that we run for students that are part of our Edge Canada GIS Centers of Excellence program. And so it's this like annual app challenge which they do. And one of the things I always warn them about is like be flexible on like your project, because you can spend the whole week which they have on it just trying to find that one piece of data that would like do do everything that they want, but then they don't have any time to actually build the app which they want to make. So it's challenging. You have to be very like flexible around how you do your project to match whatever data you can find.
Yeah, absolutely.
And in our missing roads, that's why I have all like the fake missing roads where I pulled it out of the image, so that we can actually train it on like something, because there's
Yeah.
no data on like missing roads. Otherwise they wouldn't be missing.
Is there anything you found that like we have like I'm thinking Canada, like geospatially Canada, that we have lots of data on, but we haven't done anything with?
Oh, that's a good question. I'm not really sure.
I know it's a loaded question. I don't
Yeah.
expect you to know the answer. This is just what's going through
Yeah.
my head.
I think it's hard because you don't always know how data is being used until it's made public in some sort of product, right?
Mm.
So like one of my co-op jobs was with Agriculture and Agri-Food Canada, working on their crop inventory map, and that's like a national map of what crops are growing every year. And so that was the whole like team making that. And I'm not actually sure who's actually using it, right? So like
Hmm.
it's a great product to have, but I never personally saw who was using it just as a co-op student, right? But
Yeah. All right, I'm gonna stop recording just for the
okay.
group here.